Okay, so for growth models, can you see the screen, everyone? If you can't see the screen, please let me know. Okay. Okay, so I can see a couple of thumbs up. So I hope everything is going on right. Okay, so for growth models, we want to see how can we um, formulate um, a general idea, and from that, how can we derive um, a conclusion for future for future prospects. So what I mean with this, if you can see the screen at page 173, if you have the book in front of you, please have that open. Let's say you have, let's just say that you have 20 bottles, okay, of um, Pepsi, and I want to know how much will you have after 5 months if you keep getting 5 new bottles every month. Okay, so that's what I'm trying to do. I'm trying to formulate uh, a general. I'm trying to generalize things, and then I'm trying to formulate a formula from which I can get how many a particular thing, how many bottles in for this particular problem um, will have after a certain time. So that's what we'll try to do mostly in this particular topic. Okay, so for that, please have that open, and I'll now start sharing my iPad because I need to write things. So let's do that now. So if you have seen example 1 and 2, I guess you have already seen what we are trying to do. If you haven't, I will soon see what we're going to do. But for this particular topic, my quick suggestion would be to go over the examples before you join class. I know you had less time for this lecture because I actually made an announcement last night, so that makes sense. But uh, I'll let you guys know beforehand, at least one day before you join next time, so that you can see those examples. Okay. All right. Okay. So that's my screen. Sorry for the delay. All right. So you had, let's say, 32 bottles, okay, to start with. And I said, you keep getting 5 new bottles every month. Okay. So my question would be, that's every month. So let's write month. So if I ask you, how many bottles will you have after, let's say, 40 months? Okay, for a larger number, because it's easier to calculate for a smaller one. You don't need to formulate anything. But let's say we want the number for a uh, uh, large number, whatever it is, whether it's defined in terms of months or years, depending on the question. So let's say we want it for 40 months. So can you imagine what's going on? You already have 32, right? And you will have 5 more each month. So let's say after first month, you will have 37, right? because you'll get 5 more. What will happen in the second month? So in the second month, you can either do this way. I mean, you had 32 to start with, and after 2 months, as you have 5 bottles per month, in 2 months you'll get 10, right? Because 5 per month, so in 2 months you'll have 10, so you'll have 42. You can do it this way, or you can actually add 5 to the total you had after first month. Can you see what's going on? This is the amount you had after month 1. You will add 5 more, right? Because you are getting 5 new bottles every month. So after second month, you'll have 42. Either way. Let's say what happens after 3 months. So once again, after month 2, you have 42. You will add 5 more because of this information. So after month 3, you'll have 47. Or you can do this way as well. You had 32 to start with, and in 3 months, you will add 15 more. So you'll have 47. Either way, you get the same result, right? And you can keep going on like this to get how much will you have after 40 months. So can you see how can you actually generalize the idea? You can always keep adding +5 to what you have in the previous month, right? Can you see that? You added 5 after the first month's total, you add 5 after second month's total, and you can keep adding that. So you can actually say, so let's say it's for bottle, so let's say that's B for bottle. And after nth month, I'll have this. Why? Because as I said, this is what you had the month before, and you keep adding 5, right? Each month. So whatever you had after, let's say, 20 months, you'll have +5 added to the total in the 21st month, right? So that means this will be the current month which you are looking for. This is the month before that, and this is the total you will be adding each month. And of course, you can have B naught, which is the initial amount of bottles or whatever it is you had to start with. This way, you can formulate the idea. Now, if you just keep plugging the values for n, you'll get the result. So let me write it for you. So that's 32 to start with. And then this will be your formulation, right? And for this one, you can see we keep adding that initial value, okay? And we keep adding the number of months rather, times the amount of new bottles each month to the initial number of bottles. You can see that's the initial number of bottles you had. So let's say that's B naught. Okay, I'm just saying B, but you'll soon see we actually have certain notations for this. So 3 is the number of months, right? So that's n. 5 is the number of bottles you add each month. So this might be it. You can actually do that as well. Okay. All right. So any question up to this? I mean, we're just starting the idea, but can you see what's going on here? Can you imagine? Can you use your intuition to see, to visualize what's going on? Take a minute or two, and if you have any questions, if you have any doubts, you can ask questions. Anyone? No questions at all? All good? Okay, that's good. Let's carry on then. Let's see one example and hopefully it will make more sense. Before that, we want to define what we have done so far. Okay, so as you can see, we are using uh, recurrence here. That means we are actually taking um, uh, the previous months or previous value for getting the new result. So there is a kind of recursion there. So we say it's the recursive form. You need to know how does this look, because the question often will be saying write the recursive form or write the explicit form, which is this one. We'll soon go to that. So you need to know which form um, um, look like this. I mean, how does this recursive form look like? How does the explicit form look like? So you need to know that. Otherwise, you might be in trouble. So the question will probably say specifically which format they want you to write. So it's really important to know uh, how does this look like, okay? And the explicit form looks like this, where you will actually use the initial value uh, and you will add the number of um, months or years, I mean, after a certain time period, which is n, times what or how many will you add after each time period, okay? So within that time period, how many will you add? All right. So this is the explicit form. Again, pardon my bad handwriting. If you can't understand, just let me know, okay? You have this on your book, but if you still, excuse me, can't understand, just let me know, okay? All right, let's do one example. We'll start with yeah, we'll start with example 3 and then we'll actually come back to example 1 and 2. So example 3, okay, it says the cost in dollars of a gym membership for n months can be described by the explicit equation Pn equals to 70 plus 30n. What does this equation tell us? So that's a really good question to identify if we can. My apologize, my Zoom is not working. Okay, is she waiting in the waiting room? I don't think so. Okay, probably uh, it's a technical issue with the Zoom. Anyway, so it's a really good example to evaluate or to identify whether we actually understand how does this actually work, how does this work, what does this mean. So the question has already mentioned that this is the explicit form. Even if it was not mentioned, you can clearly see it's not recursive because it's actually using the initial value, some sorts of initial value, and there is a time period, and for each time period there is a certain amount as well. So that's the explicit form. So now we want to derive information from this. We want to see what does this equation tell us. Okay, what can we understand from this? Okay, so this is for a gym membership. Let's say this is for the half-acre um, fitness center in our campus. Okay, there's certain membership fees for that as well. So let's assume that this is for the gym membership. Now, as you can see, we have a 70 added to some um, value which is related to the time period. But this 70, as you can see, doesn't matter what your value of n is, where n is months, this 70 is always added, right? Can you see that? So it doesn't matter how many months of membership do you need, this 70 is always there. What does this mean? That means this is the initial cost. Whether you join the Zine for 1 month or for 12 months or even more, you at least need to give them $70 to start with. This is the initial fees for that. Okay, that's the initial membership fee, you might say. Then, depending on the fact how many months you want, how many months of membership do you want, this will give us, let me use a different color, this will give you the fees for that. So let's say you'll join the gym for only this semester, for this 5 months. So n is 5. So for these 5 months, you need to give them 150 plus the initial membership fee, which is 70. So for 5 months of membership, you need to provide them 220. That's the amount you need to join the gym for 5 months. It doesn't need to for 5 months. It could be derived for any months. You can actually calculate the amount for any given months. Okay, so this is an actual evaluation. What does this explicit form mean? Any question from this before I move further? Anyone? No questions at all? Okay, then let me write one for you and see if you can understand it or not. Okay. Let me, it's this. So, Okay, so this is another explicit form. Oops. Okay, and this is for spectrum. So if you take spectrum for Wi-Fi connection, if you want to um, have spectrum connection in your apartment, so they'll say that, hey, this will be your billing cycle for n months. This will be your uh, bill, overall bill for n months. So can you tell me what does this mean? You can volunteer yourself, or I can ask you randomly if you want. Anyone wants to have a go at this? Even if you're wrong, just you can go for it, no problems. No one? Aston, are you there? Can you hear me? Aston? I don't think he can hear me. Okay, okay. So can you tell me what does this mean? If you can kindly unmute yourself. Let's say that's the billing statement for Spectrum. I want to um, go for Spectrum for Wi-Fi connection in my apartment, and they're saying you need to pay this much for n months. So can you tell me what can I understand by this equation? Okay.
I can jump in and give it a try.
Yeah, sure, sure.
Okay. So I think what they're saying is that the initial fee for starting with Spectrum is $70, but then every month you have to pay another $32.50 on top of that.
Okay, so if I make a contract with them for, let's say, 12 months, how much would I need to pay them? Someone else, let's say, okay, who's next? Apologies, my Zoom is not working well. Okay, no problem, no problem.
I think I can give the answer.
Yeah, sure.
So you'd multiply 32.5 times 12.
Okay,
Gives you 390 plus 70 is $460.
perfect. So that's the initial value. So doesn't matter how many months you make a contract for, you need to pay at least 70 for the initial connection fee. Okay, and let's say if I make a contract for 12 months, that means I need to multiply this monthly fee. This is actually a monthly fee. Can you see that? That's quite interesting, right? You can actually see, because most of you have actually used this, probably not in this way, but you have been using this when you actually when you made a contract with them, or when you are paying the monthly fees, monthly bill for them. So that actually is a real life problem. You can actually relate this to uh, your day-to-day life. So that's really interesting. So that's the monthly fees, as I said. So you need to multiply that by the number of months you want to make contact for, which I assume 12 for this problem. So that will give me 390. I shouldn't add 70 straight away, though. Erase this because this might create confusions. So this 390s is the 12 months total fees, right? Plus you need to add 70, the initial fees, the connection fee, so which is 460. So that's the amount you need to pay if you want to have their service for the next 12 months. Okay. Any question from this? I'm not going to go any further if you have any question from this, because this is really the basic you need to solve any problems we need to deal with in near future. We can see in our book. So it's really important you actually understand what's going on here. These are really basic things, as I'm repeating, because you need to see, first of all, you need to understand how can we formulate this, and if the formulation is given, we need to see, we need to understand what can we derive from this. Okay, you can still take a minute or two. If you want me to rediscuss any of these things, I'm more than happy to do that for you. All good? Okay, I hope so. Let's move further and we'll soon understand how things are going. So now let's go to example 1, and before that we want one more thing to understand, one more probably new concept, which is slope and intercept. Some of you might have seen this before. If you haven't, no worries. We want to get the basic idea of this first. Okay. Sorry for that. Okay, so slope and intercept. Really, really quickly, I want to give you an idea graphically, and then I'll show you the equation for it. Okay, so if you have a graph like this, okay, which is x on this direction and y this direction, and let's say you have straight line which goes like this, goes through the x and y axis. Okay, so intercept is actually where this line intersects the axis. So as you can see, this line intersects the x-axis on this point. Can you see that? Just eyeball it. This green line intersects this x-axis, which is this, at this very point. Okay, it goes through the x-axis at this point, right? So we say the intercept, the x-intercept is this length, starting from the center, which is 0, 0 by default, if uh, uh, nothing else is mentioned. We by default say it's 0, 0, it's the center. So this length is called the x-intercept. Okay. Same goes for y-intercept as well. First of all, we want to see where does it intersect. So it intersects the y-axis at this point. Can you see that? Just eyeball it. So that means this length starting from 0, 0 is called the y-intercept. So this is the intersecting point, and the red one is the x-intercept. Okay. Again, this is the intersecting point, and this length is y-intercept. Okay. So this is the graphical representation of y-intercept and x-intercept. I mean, this is for intercepts. We can have more than one intercept, as you can see. Okay. Next, we want to see slope. What does the slope mean? Okay. So slope, we denote it by m, is basically, in maths we say, the change in y over the change in x. So that's slope. That means, let's use another graph for it. And then I'll combine these two ideas to show the equation for it. So let's say this, okay? And I'll take only this portion to show the idea of slope, okay? Let's say that is the point 4, that is 5 on your x-axis, okay? So if I go from this to this 4 to 5, what's the change in x? The change in x is this yellow portion, right? You can eyeball it, right? You don't need to go for explicit calculation for it, even though it was fractions. Doesn't matter. You can actually eyeball it. So this is the change in x. What's the change in y? You need to see the corresponding values first. So, okay, let's use the same color. So if you just try to see what's the value on the graph for those particular points, you can see this is the corresponding value on the graph for 4, and for 5, the corresponding value on the graph is this. Can you see that? So the change in y will be this. So we say the slope is actually the ratio of these two. So the change in y, let's say this function has a value 10 here and 12 here, okay? So what's the change? Anyone? For y, the change in y, we have gone from 10 to 12. What's the change in y?
2.
2, very good. And what's the change in x?
1.
1. We say the slope is 2. It's really easy. Can you see that? You just need to remember that slope is basically the change in y, and change in x, the ratio of these two. You already know what does the ratio mean because we have seen this in our first content, which is problem solving. We know how does this ratio and all work, okay? We have different formulas or ideas or different ways to remember what does this M signify, but you can clearly see, if you remember the change in X and Y and take the ratio of this, you can actually reach the slope. Okay, now we want to combine these two ideas, which is slope and intercept, and see if we can find an equation for this. So if the slope is M and the y-intercept is B, we say the equation of this particular line, which we are considering for those particular slope and intercept, will be y equals mx plus b, where m is the slope, b is the y-intercept. This is the equation. Okay, so this is the algebraic format for slope and intercept, the combination of slope and intercept. How can we find that? For m, this is the same idea again. I have already shown the algebraic idea for that. You need to take the change, the ratio of change of y and change of x. Okay, how can you find b? So b is basically, as you can see from this graphical representation, b is actually the point where x is 0. Can you see that? That's the basic idea again. This is y-axis in orange. This is the y-axis, okay? And on y-axis, the value of x is always 0 on this particular line, on this orangish line. X is always 0. And by definition, our y-intercept is the length from the initial point, which is 0, 0 by default, to the point where the graph intersects the y-axis, which is this, right? Which is this. And you can clearly eyeball that line is intersecting the y-axis. And on y-axis, we have said the value of x is always 0. So algebraically, if you plug in x equals 0, you'll get your intercept. So that's the algebraic way to find intercepts. You'll soon see examples of this, and hopefully it will make more sense. But for now, if you have an equation like this, let's say y equals mx plus b, this m will mean slope, this b will mean intercept, y-intercept precisely. And for slope, you need to find the change in y and change in x, the ratio of these two. And for b, just plug in x equals 0 in this equation. You'll get your b. Okay? So that's the short summary of it. Any question from this before we go any further? Anyone? If you have any question, you can ask. No questions? All right. Let's move on then. Okay. Now, we want to see why we are getting this concept of slope and intercept. I mean, we are doing growth models. We have seen the recursive form, we have seen the explicit form. Why do we need this slope and intercepts for this topic? So if you remember the explicit form, let me write it for you. Pn equals to, that's the initial one, n times d, right? If you remember, that's the explicit form. And if you relate these two, you can actually see there is a kind of symmetry between these two. We can actually relate these two things. There is a relation, right? So for the explicit form, this is actually the y-intercept, which is b for this format. And this will be your slope, which is m for this format. So if we write this format, this explicit format, our P naught is y-intercept and D is the slope. So now we can use the same idea to get these two values. Okay. And now, as we are not going to graph it, we want to rephrase the words, changing y and x in a way so that it makes sense for our problem. So we'll be given data, right? We'll be given certain data or a table, in the form of table, from where we need to identify these two values. Soon you will see examples of this. So for this, we want to write this way. So change in output over change in input. So this will be your slope, which is D in the recursive form, or rather explicit form, my bad. And no worries, this will be given. This both of these outputs and inputs, this will be given if the question wants you to find the slope, I mean D for the explicit form. So this will be the formula for slope. And finding y-intercept, the idea will remain the same. If you plug in n equals 0 here, like the way we have done for x, we'll plug in n equals 0 and we'll get p naught, which is the y-intercept, or if you write it for this problem, which will be the initial value for whatever given information. Okay, so you need to remember the formula so that you can calculate this. So let's quickly go over one more example before we wrap it up for today. So for example 1, it says in 2003, the population of elk was 12,000, and in 2007 it became 15,000. Okay, so the question wants you to find if the population continues to grow linearly at this rate, what will the elk population be in 2014? Okay, so the first important thing is to identify what does this n mean here. Is it in year? Is it in months? What does it mean? So for this particular problem, we can see this is what? This I'm just fed up with the spam calls. I need to stop this. Sorry for that again. So you can see this is in year, right? Year 2003, year 2007, and year 2014. So you can clearly express our n in here, right? So if we want to find anything like this, we want to calculate this P naught and we want to calculate D. Then we can actually eyeball n because we started at 2003 and we want to calculate up to 2014. So we can calculate n from this. But first of all, we need to calculate P naught and D. But we'll do this next time because we're almost at 9:30. So I'm not going to continue this anymore because I guess one of you have class just after this. So we'll stop it here today. So your job will be to go over examples 1 to 4 before we meet next time. Okay, and we'll continue it from here on Wednesday. Okay.
Thank you.
Bye-bye.
Thanks.